I was wondering what the hell took you so long.
I'm like, gotta go to the first floor.
You got some homework for me?
Oh, I forgot to do it.
Yeah, I know.
You're just awful. I hope you can decipher my hieroglyphs.
I'll give it a shot.
Yeah, I don't know sometimes how you read some of the things that people write.
Oh, you? Thank you. Thank you.
I forgot my water bottle in that phone.
Thank you. Don't let Haley get it or else it's burden.
It's not that one, actually. I left that one in the softball locker room.
Oh, goodness. All right. Questions about anything before we get started? Did we actually watch the videos? I know Sydney did. All right. So,
Dr. Joe, I have questions on anything.
What's that?
I have questions on anything.
Okay.
So, for exercise number 2 on chapter 5,
Okay.
whenever there's a term that's in between 2 times, like as you see 0.03, do we still use the integral function if it's between a time? Or do we just set that as 0.03 times 4 years?
You mean
Because
for
there's no t term in it.
you can? I mean, you can do it either way.
It'll get you the same.
It'll give because if you integrate 0.03, you'll just get 0.03t, and then you'll plug in the endpoint, so you'll get the same thing. So you can do it either way. All right. Let's see about. Now, let's first talk about the other annuity formula that pops up in this section, and then we'll talk about some of the problems and just basically have you work on some problems today, I believe. So, last time we talked about annuity immediate. Which we said that meant that the payments or deposits or whatever you're talking about are made at the end of each compounding period.
Hey, they unlocked the door.
Because they did unlock the door today.
I expected it to be locked.
Oh, there's no water.
Really?
All right. So there's also the concept of the annuity due, which in this case, instead of making the deposits at the end of each period, they're going to be made at the beginning of each period. So we can derive a formula for annuity due, just like we derived the formula for annuity immediate. Let's think about time diagram again. So we're gonna, in this case, we're gonna have this annuity. It's gonna make payments, or we're gonna make payments into it, whichever way you want to look at it. Hey, Marshall. It's how much? So we're going to make payments into this annuity or on a loan or any of those kinds of things at the beginning of each period rather than at the end. So we're still going to make, over this time period from 0 to n, we're still going to make n total payments. Let's assume for the starters that we're just going to make a payment of 1 each time. So in this case, though, instead of having our payment start at 1 and go up to n, like we did for annuity immediate, for annuity due, we'll have our payments starting at 0 and ending at n minus 1. Again, there's going to be n total payments overall, but since we're going at the beginning of each period, our last payment will be made at time n minus 1, not time n. Does that make sense? So in both cases, in both your annuity immediate and annuity due, you're making n total payments. We're just shifted off by a time period. All right, so just thank you, Marshall.
Fair was not forgiving.
Just to emphasize that again, I'll write up here that we're having n payments being made over that time period. All right, so if we want the present value again, much like we did with annuity immediate, I've got to move all of these payments to time 0. Notice though in this case our first payment is already at time 0, so I don't need to do anything with it, right? It'll just be a 1. What will our next payment be at time 1? What do I need to do with it? I need to discount it by a V, right? So it'll be a plus V. This one at time 2?
Plus Z squared.
Yeah, plus V squared. Yeah, I know. At time 3?
V cubed.
V cubed. And all the way up to
Vn minus 1.
V to the n minus 1?
Or is it Vn?
Well, this one will be n minus 1 because it's at time n minus 1. So the n minus 1 was right. Yep. Notice again, what kind of a series do we have here? It's geometric, right? So remember, this is a finite geometric series. So we have a formula for that. What was the formula?
X to the n minus 1.
So 1 minus
X to the n.
x, or in this case, it'd be v to the n, right? And then over 1 minus v. Remember again, the exponent that's up here, right here by the n, the exponent that's here is 1 more than the exponent here. That makes sense? All right. We have one little simplification that we can do on this formula. What's another way to write 1 minus v? Using a single variable or a single letter, what's another way to write 1 minus v? Another letter that we've used.
D.
It's not I, it's d, right? Yeah, so this one is 1 minus v to the n over d. Notice that so we had the annuity immediate formula last time. It was 1 minus v to the n over I. The annuity due, it's 1 minus v over d. So you have to remember which one is the end of the period, beginning of the period, but immediate uses I, due uses d. So you at least get a little bit of a mnemonic to remember the letter that goes in the denominator. Otherwise, the formulas are exactly the same. Okay. So we use a very, very similar symbol, and Sam asked about this last time. We use a very, very similar symbol for annuity due as we do annuity immediate. We put the little umlaut over the A. So this little umlaut here over the A is signifying that we're doing an annuity due rather than annuity immediate. All right. So let's look at, see if we can find one here that has beginning payments. Let's look at, this is not on your big packet of stuff in chapter 6 exercises. Let's look at number 8. It's kind of an odd setup, but we'll go with it. So the person is going to buy an annuity, so they want to basically they're going to pay a lump sum of money now to guarantee that they'll have a fixed income for the next 15 years. Okay? So they're going to pay $300,000 now and get back, what does it say, X at the beginning of each year for the next 15 years? At an interest rate of 6%? Yeah? Is that what we have? Not getting much agreement, so I'm just trying to figure out and make sure we're all on the same page. All right. So, in this case, we're given the present value, right? We're given that the present value is $300,000. I know that because it says that Connie pays $300,000 now. So I know I'm given the present value. And then it says receives in level payments at the beginning of each year. Since it's level payments, we're going to have payments that won't be level here in the next couple of chapters. But we have level payments at the beginning of each year. So it's regular payments, same amount, at the beginning. That's annuity due, right? So just to write that down again, level payments at the beginning of each year. Oops. Gives us an annuity due. All right, so this formula that we came up with, this A umlaut bracket N, A double dot N, probably say that versus umlaut because it's easier to say. The A double dot here, this A double dot bracket N, that's our formula for the annuity due. But what did we assume the payments were to start with? 1, right? So if I had payments of, say, 50, what would I need to do to figure out the present value? Just multiply by 50, right? Again, this is our accumulation factor. If we're doing an accumulation function, I just need to multiply by the present value, correct? So in this particular problem, we're already given the present value and I don't know the amount of the regular payment. So we can set up N was 15. So I can set up our equation as 300,000, that's the present value. It's equal to the amount of the level payment, which we don't know, they call it X, times the present value of our annuity due, the A double dot bracket 15, with an interest rate of 6. 0.06, 6%. Now, we could use our formula. Given I, we can certainly figure out what V is and what D is, right? Right? But rather than having to use the formula and get all these pieces, let's use our calculator. So let me get over here and see if I can get the calculator up on the screen. Try to get off the glare. All right. So there's a calculator. We're going to do time value of money stuff again. So let's clear that out. Make sure we don't have anything stored in the values for the time value of money. Now we did these buttons last time for annuity immediate. Hopefully it's pretty obvious that I can't do the exact same thing for annuity due as I did annuity immediate, because why would I give you the same answer for two different contexts, right? So there must be something that we can do to the calculator to start with that allows us to get the value that we need. And that thing that we need to do is we need to use this BGN right here above the payment. Okay, so we'll do second BGN. Notice right now it says end. So what that means is that the payments right now are set so that it's going to calculate like they're at the end of each period. So if we want to change it, we'll do, I almost tried to type the calculator buttons on my computer screen. second set. Now it'll go to the BGN mode. And then we can do second quit and get out of there. Notice now, you can also tell that you're in BGN mode on your calculator because you've got BGN right up there above the number. In my case, above the zeros. All right, so this is probably one of the biggest calculator tips I can give you. Pay attention to that begin mode. It's very, very easy to forget to turn it into that mode, but it's even easier to forget to take it out of that mode. Okay? Because depending on the problem, you have payments going into the beginning of the period or the end of the period. You need to make sure you're in the right mode. And it's easy to forget to switch it, which of course will throw your answers off. Okay? So that's just one of those be careful kind of things. Make sure that you're in the right mode. All right, so this one then, we are given the present value of $300,000. We're going to assume that annuity will be exhausted at the end, so the future value will be 0. So we're given present value, we're given future value, we're given interest rate, and we're given number of periods in this problem, right? Yeah, Grace.
Are we always assuming the future value is 0?
No.
Why are we assuming that here?
Because when you buy an annuity, when the annuity ends, there's not any value left in it. Now, it's possible that there might be a little left in it, or it's possible that, for example, when we do bonds later on, you'll pay a certain amount to buy the bond, and then you'll be expecting to get an amount at the end back. That's when we'll have a future value. In this case, when you're just buying the annuity, or think about it this way, it says she paid $300,000 and got these payments back. Think about it the other way. What if you borrowed $300,000 to buy a house and then paid it back for a loan? You don't want there to be a balance at the end. So the future value would be 0, right? If you pay the loan off, you want it to be 0 at the end. Right? If you're paying your student loans off after you graduate, you don't want to say, oh, I'm going to pay it for 10 years and then have a balance at the end. Right? You want the balance to be 0 at the end. It's the same idea here. If we think about this, she borrowed $300,000 and is paying back the payment, she'll want to pay it off at the end of 15 years.
This might be a stupid question, but what's an annuity?
Say it again?
What's an annuity? Like, I know what a bond is, or like a loan is.
So, one of the things that you might do when you get a job is save for retirement. So as you're saving for retirement, you're building up some sort of a chunk of money. From that chunk of money, you want to be able to, basically at the end, buy an annuity that gives you a regular payment stream, like you still have income even though you're not working. So that's when you purchase an annuity, that's what you're doing, is that you're trying to purchase a financial instrument that allows you to still get paid. You didn't like that answer?
Do you have to pay to get your own money back?
No. What you're doing is you're saving up. You could take your whole chunk out at once and keep it if you wanted to, right?
Yeah, but
you don't want to do that, right? So what you want to do instead is you want to leave that chunk there, let it accumulate interest, and basically the interest that's being earned on what you saved up is just getting paid to you, and that chunk still stays there. So then that's actually what I'm actually defining here as perpetuity, but that's the idea. Is that you have this money, you pay it up front, and then you get an income stream coming back to you on a regular basis.
okay.
I mean, if you save for retirement, you can take the big chunk out all at once and keep it.
So really,
But you probably don't want to do that.
they're only used for retirement, is what I'm getting.
No, not necessarily. Bonds are a type of an annuity as well because, for example, the university here will sell bonds to borrow money. When we sell bonds, we make what are called interest-only payments to the person who bought the bond. But that's an annuity to that person. To whoever bought the bond, they get an annuity because they get interest payments. So they laid out money ahead of time to get money back. So they laid out a chunk of money to begin with to get money back on a regular basis.
Then they get more money back at the end.
Yeah.
Why does the university?
Doesn't sound like the university's borrowing money, does it?
Because it's when, like, the university needs money,
then that's like how they get it fast, is for purchase bonds.
Yeah, they get the money fast, and then they still have to pay it back, but they pay back with interest. So if you pay interest on the, because what happens when you pay an interest on a bond, we're going to talk about this when we get to bonds, but when you pay interest on a bond, the principal doesn't go down.
Okay.
You make an interest only payment, so the principal just sits there.
I gotcha.
So they're making these interest payments to these people, and then at the very, very end, they'll give them the bond money back.
So you make more.
Yeah, you make more. Yeah.
Gotcha.
Yep. And the university's paying interest on it. Or, and not just universities do bonds. Any business that does capital projects will typically fund it with bonds that way.
Gotcha. More you know.
What's it? More you know? Well, we'll talk more about bonds as we go along.
How do I buy a bond for the university?
What's that?
How do I buy a bond?
Well, first you better have a crap ton of money. Because the bonds are not small. So, if you have a crap ton of money, then you can buy a bond. Anyway.
Do you have a bond?
Do I have no? I don't have a crap ton of money. I'm a college professor. Are you kidding me?
She's just all about money. You have all that money for yourself.
No, that's not how it works. All right. So in this problem, we were given that the present value is 300,000. So we'll type in 300,000 to hit present value. The interest rate was 6%. So I hit 6 and do the interest of the I/Y button. It was 15 total payments. So I'll hit 15 and type in N, and then we'll compute the payment. Notice I didn't put anything in future value. We cleared out the time value of money. So the future value would have been set to 0. Notice again that we put in a 300,000 positive, and it came out with payments that are negative, because again, that's the idea of money going in, money coming out, having opposite signs. And we'll discuss that even more later on too when we get to bonds. In some problems, if you don't have your signs, if you don't make sure that your signs are opposite, it'll give you an error. It won't be able to solve the problem. We'll talk about why that is when that happens. Is this okay? Any questions on that? All right, let's look at one of these that's talking about a deferred annuity and talk a little bit about what we mean by that. So let's look at number 11. Same packet, but let's look at number 11. Oops, I guess I gotta just go back. Oh, wait, I didn't do that. Sorry about that.
Number 11.
Yep, number 11 on the packet, yep. All right, so it says calculate the present value of an annuity with 30 annual payments of 300. But the first payment doesn't occur until the end of the 5th year. All right, so it's 30 annual payments, but the first payment doesn't occur till the end of the 5th year. We know it's 300 for each of these. I don't know why I draw such long lines. When will the last, if the first payment is going to be at time 5, when will the last payment be made?
34.
It'd be 34, right? Be a little bit careful. It has to be time 34. And then we'll have nothing past that point. All right, so this is an example of what's called a deferred annuity. Because it doesn't get started paying immediately or even after the first period. It's some period in the future where we'll actually start paying it. But this particular problem is asking us for the present value now at time 0. So tell me a way that you might try to approach it. Okay. So you want to take these. Well, we can think about it with. So you're thinking about doing it directly. Just take all the 300s and moving them all back, like we did when we developed the formulas. So you're like thinking, take this 300 and move it back. Take this 300, move it back, and make a geometric series. Is that what you were saying? Something along those lines. Well, you could absolutely do it that way. You could do to move that first 300 back. What would you have? V to the 5th, and then 300 times V to the 6th, all the way up to 34th, right? Because I take all of those back, right? We agree? Okay. It would be 1 plus V. Plus V squared all the way up to V to the 29th. You were right the first time. 1 minus V. Right? All right, so, okay. So we can absolutely do it this way, going back to basically first principles, right? This is literally going back to first principles, isn't it? Taking each individual payment, moving them all back to time 0, and then using our formula for geometric series. But didn't we just have a name for this last piece? What was this? That's the annuity due, isn't it? So this is, let me write it this way, V to the 5th times 300 A double dot bracket 30. And then what was the interest rate, did they tell us? 0.06. They love the 0.06.
So is that discounted?
Yeah, exactly right. It's discounting the annuity due. That's exactly right. So what does this part right here basically treat what's going on? This is an annuity, this is the present value of an annuity due with payments of 300, right? So this would give, instead of being present value though, it's giving you the value of the annuity due at what time? Well, remember your annuity due again is payments are at the beginning of the time period, correct? Right? So this part, this 300 times A double dot bracket 30 would be the time right there. Would be the value at time 5, right? Because the 300 is being made at time 5. If we think about making payments at the beginning of the period, that would be where that present value calculates it to, right? So we found that part right there that I've got the square bracket over the top of, this part right here is value at time 5, but I want value at time 5 to be moved forward, moving backward 5 years to get to time 0. So we multiply by V to the 5th. Does that make sense? So I wouldn't have needed all of this stuff in the middle. I could have written this with this formula to start with and gone from there.
So that's how you convert from immediate to due.
That's not quite how we do from immediate to due. I mean, we can. I was going to talk about that here in a second. Because I was actually going to ask you, can you come up with a similar, not exactly the same, but a similar formula using annuity immediate rather than due. So this is annuity due because, again, the 300 at time 5, we're treating that like it's at the beginning of the period. Can I come up with a similar formula for annuity immediate? It'd be both, yeah. Instead of it'd be the same kind of thing. Oops, not dot. But do a v to the 4th, right? Because in that case, my 300 would be at the end of the period. The period right before 5, the period right before 5 ends at 4. So the A without the double dot, the annuity immediate, would then take your present value at time 4, which then we still need to step back 4 years. Does that make sense? Okay. So do this on the calculator real quick. I'm already in begin mode, so I'll do it with the first method. 300 was our payment. 30 was our number of payments. 6 was our interest rate. And we want to compute the present value. But again, this is not value at time 0, this is value at time 5, right? And notice I had it in begin mode, so I really was using the first formula. So I need to move it back. I still need to move it back 5 years. V is 1 over 1 plus I. So I need to do 1 point, oops, crud. I lost my value. I need to multiply that by 1.06. I gotta flip it. So I use the reciprocal button. And then I gotta raise it to the 5th. Now my calculator is set in order of operation mode, right? So it will know to do the exponent before the multiplication. If you have yours still set in chain mode, you have to be careful. So you should get 32, 70, 91. In particular, if you have yours set in chain mode, or if I would have had mine set in chain mode, as soon as I hit that the exponent button, it would have done the multiplication first. It would have done the present value that we calculated and multiplied it by the 1.06 flipped. It'll do the reciprocal before it does the, it's weird. The calculator is really weird. These 3 buttons will do it immediately when you hit the button. Won't worry about order of operations. If I hit the button, and if I type in a number and hit square root, it'll automatically do square root without doing anything else. It'll take the square root of what you typed in. Same thing with reciprocal, same thing with square. Those 3 buttons will just do it. Whatever's typed, whatever you typed in, it'll do it before it does any other operation. Okay? However, if you do that exponent key, if you're in chain mode, it won't know to do the exponent next. Okay? It'll do whatever you've typed in, it'll do that operation and raise the whole thing to whatever power it's in. Okay? Just give me a look. I know, but when we have problems where we have to solve for the interest rate, you're going to love this calculator. Because you won't be able to do it otherwise.
Why not? Use the other one.
You can't. It will be because where the eyes appear. So for example, if you have, if I have this value and I know n and I want to figure out I, I've got it in 2 different places. And I can't get it by itself, except in very special cases. If this n is bigger than 2, for example, you're in trouble. Okay, so yeah, it just won't work, unfortunately. And even if it's 2, it's hard. But if you get anything that's bigger on that exponent, you just will go with my hand. Just look at use that calculator. Because you're not allowed one of the other graphing calculators to be able to do it. So. This one okay?
How come they don't let you use graph?
Because you can store things in it when you go in.
Don't they reset it anyway?
They reset it anyway, but some people don't want their graphic calculators reset either. So, plus, they just say you can only use this small finite set of calculators, and they don't have to monitor nearly as much. Because you got to remember also that they are outsourcing their exam to services, and they want to make sure that you don't want to have to look at 85 different types of calculators, not to reset them all. So, since they're not in charge of it themselves, they're actually outsourcing. It makes it easier for them that way too. All right. Okay, so let's talk about perpetuities. Change back over to black here. Perpetuity is basically the same thing as annuity, except it doesn't stop. Perpetuity just means the payments go on into infinity. They go on forever. So these are regular payments that continue forever. I guess I didn't mention when I did the Annuity Due formula. There's a corresponding formula for future value, just like we had for annuity immediate, remember we had the S bracket N, right? There's a corresponding formula for S double dot bracket N. Remember, for S bracket N, it was 1 plus I to the N minus 1 over I. The only thing that changes is for present value. Instead of an I on bottom, it's a D. Same formula. Same exact formula. Now, for perpetuity, does it make sense to try to figure out future value? If your payments continue on forever, does it make any sense to try to calculate future value of perpetuity?
No.
No. So the only thing we're worried about with perpetuities are present value, which again makes sense. Again, if you're thinking about, for perpetuities, you want to have a guaranteed income forever, because you don't know how long you're going to live, right? You don't want to try to I'm only going to live another 10 years, and then you live 30, right? You don't want to try to guess how long you're going to live, right? Yes?
Do the payments continue even if you die?
Yeah, you can usually will them to someone else, yeah. That would depend on the terms of it, but for example, with my retirement account, they can do a beneficiary for that purposes. And again, the whole idea is to be able to have the perpetuity at the end. Now, an example of a perpetuity that wouldn't necessarily is Social Security benefits do lapse eventually. It doesn't continue to your child and the next child and the next child. So those do eventually end. But it's also another example of perpetuity because you'll get Social Security until you die. Usually your spouse will get it if you die too. But after that, I think it stops. Surviving dependent children get it, but it will stop when they get of age to adulthood. If I'm remembering all those things correctly. But yeah, a retirement account would continue. It would go to some other person. Usually at that point, what they would do instead of making the payments to that person, they would just give whatever balance was in there left. Then that would be an inheritance that way. All right, so if we're thinking perpetuity, and we want to do present value, if we want to purchase a perpetuity, again, set it up the same way we were doing before. Thinking that we have payments of 1 at each of those times. I got to move all of those back to times 0. Right? Well, how do we move the first one back to times 0? What do we do? Discount it by multiplying it by v. And the second one we would multiply by v squared. And the next one would be v cubed. And so on. This one just doesn't stop, right? This one just keeps going back, keeps going on and on and on, stepping things backward. But again, notice that all of them are going to definitely have a V in it, right? So we can factor the V out. Left with an infinite geometric series in this case. And what's the formula for an infinite geometric series? 1 over 1 minus R. Oops. So in this case, 1 over 1 minus V. Right? We said that 1 minus V is D, right? We agree? But another formula for D is I times V. This is just kind of a review of different manipulations of those formulas. So you just get 1 over I, yeah. So, yes, it is crazy. So for perpetuity, instead of an N, you use a little infinity symbol under your bracket. Still a little I. That's our present value of a perpetuity. This is perpetuity immediate, by the way. It's perpetuity immediate because it's at the end of each period. This is 1 over I. Okay? You can also, so I'll write this down right below it to make sure that we know that, maybe I'll write it right below it. Perpetuity immediate. Perpetuity to, good grief, T, immediate. We can also do perpetuity due. Well, what would be missing for perpetuity? How can I change this to get to perpetuity due? Well, think about it. Look at this piece here. This is 1 plus V squared and so on. That's been discounted one step backward, right? So we can think of this as being a perpetuity, or we can think of this as payments at the beginning of each period for time 1, and then step it back. Well, with perpetuity due, I wouldn't need to step it back, right? So that V just wouldn't be there.
So that's just 1 over D.
Then it's just 1 over D. That's exactly right. So instead of that V being out in front, we just have 1 over D. So if you want to do perpetuity due present value, that's just 1 over D. So those present values are pretty straightforward to be able to calculate. Again, it's not a huge surprise that that's what the formula is, because remember, here's your formula for A angle N, right? What's going to happen to this term as N goes to infinity? It goes to 0, right? This is 1 over 1 plus I. As long as you don't have negative interest rates, this will go to 0. Right? Because 1 over 1 plus I will be less than 1. Raise it to higher and higher powers, it gets smaller and smaller. Yeah, Grace.
Can you write down the equation for the future value of the annuity due?
Yep. I'll go ahead and write them. I'll write the other ones down too.
So there's still an I in the numerator.
Yep. The formulas are identical except for the I switches to a D. Immediate I do D. Do D. That sounded funny. Sounds great. And then for perpetuities, Those are your formulas. Now we'll also have ones for what are referred to as continuous annuities, which will also look similar to this. So I know there's a lot of words, there's a lot of formulas, but some of them are very similar, so it's not as bad for memorizing, but there are a lot. Definitely, without a doubt, there are a lot. Is that right? All right, so next time, Friday, we'll basically do a problem day. And since apparently I had said that the test is Tuesday, which I thought was Thursday, that's okay. Since the test is Tuesday, this will be the last chapter that'll be on the test.
Next week.
Yeah.
What? I thought it was Thursday.
Apparently it was Tuesday, that's what Nick said was on syllabus.
Yeah, it was.
I'm sorry, Marshall. You don't want class Wednesday.
Yeah, but we'll still have a test on Tuesday. It doesn't really change.
What if I have practice on Tuesdays?
Sounds like a problem for you.
Yeah, it does.
Personal problem. So we not have class this week on Friday for probability?
Correct, we did not have class for Friday.
We still have this class on Friday.
We still have this class on Friday, yes. All right, have a good one, everybody.
I'll take an hour break then.
Yeah. Take it where you can get it, right?